A new Wordle puzzle is online. Click on the link to play.
Listening to the following video may give you clues. Please like and share the videos.
Satellites monitor Earth's atmosphere after record-shattering Krakatoa eruption. NOAA satellites provide the high-resolution data that scientists use to monitor the atmosphere.
Satellite images show the eruption in true color photographs. The electromagnetic wavelength used to capture atmospheric waves and clouds is best suited for observing the eruption.
In addition to showing the eruption scale, compiled images reveal the air temperature and water vapor. To further understand the magnitude of the Tonga volcanic eruption, the following information has been gathered.
ICON clocked wind speeds of up to 450 mph. In January, a giant cloud of water vapor and dust erupted from the Tonga volcano, pushing a massive plume into the sky.
This caused huge pressure changes in the atmosphere, causing strong winds to expand upward and move faster. The ICON satellite recorded wind speeds of 450 miles per hour in the sting of the house, which is below 120 miles of altitude.
The record-breaking Tonga volcanic eruption spurred hurricane-speed winds and unusual electrical currents in the upper atmosphere. It caused one of the largest disturbances to Earth's atmosphere in modern history and sent fast-moving tsunamis around the globe.
While the volcanic eruption may have been large, the effects were felt far from Tonga. The Tonga volcanic eruption triggered earthquakes, tsunamis, and sonic booms around the world.
The resulting explosion caused strange electrical currents in Earth's ionosphere, which shook the ionosphere for hours after the eruption. In the coming days, scientists expect a larger Tonga eruption in 2024.
The extreme winds flipped particles eastward and disrupted a normal flow of electrons in the ionosphere. In addition to this, the equatorial electrojet, a strong wind current that flows east to west, suddenly flipped directions and flowed westward.
Those effects led to higher levels of electricity in the Enos Rothais underwater volcano in Tonga is a small island nation that rarely attracts worldwide attention.
But on January 15, it erupted and created a huge underwater volcano. Hunga Ha'apai and Hunga Tonga are uninhabited, and sit at just a few hundred meters above sea level.
This underwater volcano is approximately 180 kilometers high and 20 kilometers wide. ICON clocked infrasound signals.
Scientists have access to an array of space and ground-based instruments, as well as a fleet of satellites that monitor Earth's surface across the whole spectrum of light. The first waves of infrasound generated by the Tonga eruption were detectable by an array of sensors on the GTRI building in Atlanta.
The second wave, however, failed to register on the detectors and was drowned out by rain and other sounds in Atlanta. Tonga volcano was active last January, and the eruption created a series of infrasound waves that echoed across the ocean and across the Pacific.
These waves, which are below the human hearing threshold, were recorded on satellites across the globe. Scientists estimate that the Tonga volcanic eruption's pressure pulse matched the Krakatoa eruption in 1883 and was over an order of magnitude larger than the 1980 Mount St.
Helens Eruption ICON was launched in 2019 to study Earth-space interactions.
It had previously assumed that only space and the sun could create weather in the ionosphere. However, it was able to identify the first Earth-space interaction with the ionosphere, a phenomenon that may have had catastrophic effects.
This discovery is exciting, as it will allow scientists to develop better prediction models for the future of space. Weather scientists say that the latest eruption in Tonga may be the largest to date, with the largest explosion happening on January 15 at 5 at
Tongatapu time, or at 6:10 p.m. HST on January 14.
The volcano is currently still erupting, but the eruption has been largely confined to the Hailmama crater. While it is a huge disaster for the island, communications are being disrupted.
Scientists say the infrasound signals produced by the Tonga volcanic eruption have an explosive yield of up to 10 megatons, which is equivalent to 500 times the mass of a Hiroshima bomb. The new discoveries are exciting because the explosion occurred so far from Earth.
It was also the first to be detected by ICON's global infrasound array. Scientists at ICON have estimated the speed of the Tonga sound waves based on their observations.
The speed of the waves varies according to air temperature and air mass speed. Infrasound signals, however, can be difficult to interpret due to the way they bend in different layers of the atmosphere.
With the help of geophysical measurements, scientists can better understand how the Tonga eruption is affecting global climate. Icon clocked long-range sound waves.
The Krakatoa eruption was the loudest sound in recorded history. Residents of 50 different geological locations reported hearing the sound from Krakatoa, located between Java and Sumatra in Indonesia.
The sound traveled more than 5,000 miles from its source to reach as far as Western Australia, New Guinea and Rodrigues near Mauritius. The sound was so powerful that it covered 13% of the globe.
USGS reports the information on volcanoes in different levels, including warning. The warning level indicates that an eruption is either imminent, underway, or suspected.
Visual observations alone cannot confirm whether a dangerous eruption is ongoing or not. While the long-range sound waves of an eruption are dangerous, there is still no way to confirm its existence.
The warning level is a good indicator that a dangerous eruption may be taking place. The Hunga eruption's Lam wave has a longer wavelength than the 1883 explosion, and it rose to an altitude of 280 miles.
Scientists have used this information to improve our understanding of how acoustic waves are generated and propagated in the atmosphere. However, the 1883 wave was not as pronounced.
In the present, more data are available due to the proliferation of sensors around the globe. Researchers led a team of 76 scientists from 17 nations to study the effects of the eruption on the atmosphere.
The scientists studied the eruption's long-range sound waves using NASA's ICON mission and data from European Space Agency's swarm satellites. They concluded that the eruption generated a series of atmospheric waves that could be heard nearly 4,800 kilometers away.
But further research is needed to understand the precise mechanism behind these waves. The Icon volcano sent long-range sound waves.
Sound waves are an important part of volcanologists' work and can be used to gather important information. Scientists can use this information to better understand the behavior of volcanoes.
The sound waves emitted during the eruption are emitted from the volcano. They are recorded by instruments in the Smithsonian and Oregon State University.
If the Icon volcano was still active, the sound waves would continue to travel a long way. Although humans are not capable of hearing infrasound, they can detect changes in the magma's position.
Hence, the higher the magma in the chamber, the higher the sound produced. Similarly, the lower magma in the chamber would produce a lower sound.
The difference in the sounds indicates an active volcano. The scientists used the data from the Icon eruption to investigate whether it had any repercussions on Earth's surface.